our privilege to introduce Professor Dinesh Babu J, a distinguished academic and researcher who is currently serving as the faculty in charge for placement and internship and is an associate professor at IIT Bangalore, where he leads the multimodal perception lab. Professor Dinesh Babu sir holds a PhD in social interaction modeling, machine learning and signal processing from EPFL, Switzerland, and a Master of Science from Indian Institute of Science, Bangalore. His illustrious career is marked by numerous accolades, including the Outstanding Paper Award at the International Conference on Multimodal Interaction, that is ICMI 2012, the IDF Best PhD Student Research Award in 2009, and the DST Young Scientist Startup Grant in 2016. Notably, Professor Dinesh Babu's mentorship has led to several student achievements, including nominations for the Best Student Paper Award at ICMI 2016 in Tokyo, Japan, and the Best Student Paper Award at MedPri 2018. His impactful research contributions include collaborations with CAIR, DRDO, and NI systems, alongside executing prestigious sponsored projects. Furthermore, Professor Dinesh Babu J served as a visiting professor at the University of Lausanne in 2019. Please join us in welcoming Professor Dinesh Babu J, whose expertise in machine learning, signal processing and multimodal interaction continues to inspire innovation and academic excellence. And something really important, and it's a proud moment for me to inform you that it is our immense pleasure to inform you all that Professor Dinesh Babu J has been honored with National Award for Teachers 2023. This distinguished award was felicitated by the President of India as recognition of one of the 13 professors across India.
So thank you so much once again for coming here. I'm here, I will take just 1 or 2 minutes. I have been very lucky, here that I have worked with Professor Dinesh Babu. As the introduction was given about him, he is a brilliant researcher, very, popular academician, is very popular with the students. And I can tell you one thing, whenever I talk about the kind of, the average package that IIT Bangalore offers. So the entire placement drive is also led by Professor Dinesh Babu. What is more important thing is, I don't know whether you noticed or not, because of his immense research contribution. Last year, he was honored by President of India. So I think we are very honored to have you, Professor Babu here, Professor Dinesh Babu here. Thank you so much for accepting my invitation. Thank you so much for coming here. I hope the dear students that this interactive session will help you a lot, will help you understand what AI, what are the potentials in AI, what are the applications in AI. If you think that you are from a school of management, you are from a school of sciences, AI is not useful for you, you are mistaken. AI has become, a tool to be used for everybody. It's so powerful tool that can be used for your business, for anything. You want to strengthen, you want to empower yourself, you want to empower your technologies, use artificial intelligence. So I hope you will enjoy this lecture. Once again, I welcome you all, and thank you so much, Professor Dinesh Babu, for coming here. Thank you so much.
So I really like to move around a bit, so I will see what is best, how much I can move without disturbing everything. Okay. So, so what are we going to talk about today? What are we going to talk about?
AI.
Yeah. AI. Okay, we agree on that. So what is AI?
Artificial intelligence.
Artificial intelligence. What is human intelligence, by the way? Why do we need artificial intelligence? What is the goal? Why do we need that? Yes? You can answer, no problem. What is human intelligence? Okay, let's put it this way. What can humans do that maybe you want a robot or an agent to do? What is it that humans can do? What am I doing now? Okay, I'm walking. Okay, I can run, I can walk. Okay, good. What else can I do? I'm a human here for you. So what can I do? here, I press, I manipulate objects, okay? I use my hands, I use my legs. What else can I do? I can see lot of people there, yes? So what branches are you from? What is your background? Is it science? How many of you are from science? Yes. How many of you are from engineering, technology? Yes. How many of you are from management? Yes. Is there anything else I missed out? No, right? Is that all? Yes? Okay, so I can see lot of people there. What else? I can hear. Maybe if you give an answer, I can hear. Right? I'm also speaking. Yes. I'm also doing something. So these are some of the actions that I'm doing. Right? Can robots or agents do that?
Yeah.
For example, can you have a robot which can walk?
Yeah.
Yes. Have you seen some robot? Where have you seen such robots? Any company that makes some walking robots? Have you seen? Yes? Robots can walk. Can they talk as well?
Yeah.
Yes?
Speaking. Yes, like
Robots can talk. What is ChatGPT an example for? How many of you are using ChatGPT? See, how many of you are using WhatsApp Meta AI? Do you use that? Which one is better? ChatGPT. Why? Why is it better? Yes? Sorry? Data. What data? More data? I see. So you find that it is better than Meta model? Is it so? Yes? So you can see that robots can start to talk as well, right? So you can get the text, you can make it into voice, right? You are starting to see robots are even starting to talk, right? What else can humans do that maybe machines can do or cannot do? Is there something special with us that we can do and maybe robots cannot do? Yes?
Emotional intelligence.
Emotional intelligence, very nice. What else? Anything else? So what is intelligence, by the way? Who said intelligence? Yes. What is intelligence?
Emotions. Emotional intelligence.
Okay, emotional intelligence we seem to have. Robots are not yet there. Okay. So what are different kinds of intelligence? Any idea? What are different kinds of intelligence that humans possess? Yes? What are different kinds of intelligence that humans possess? Is somebody typing in Meta AI, Meta and like getting an answer? Did you get something? Yes? What is different types of intelligence? So not all of us are the same, right? Some of us have certain, certain skills, certain intelligence, which is probably different from others. So what are different types of intelligence? Some of you might be good at language skills. Some of you might be good at mathematics. So how many of you are good at language? Nobody. At least few raise your hands. How many of you are good at language? It can be your own language. It can be English. Anyone who is good at languages? Very less hands are raising up. Mathematics? How many of you are good at math? Okay, good. How many of you are good in music, maybe? Yes? Few more. How many of you are good at dance? Yes? Can robots dance? Yes? Have you seen robots dancing? Yes? Okay. So, everything robots are seeming to do, right? What is our role there? I mean, what can humans be better at? I think somebody said emotional intelligence, right? But we can also use robots or agents for our own work, right? For example, if I'm a teacher, how can I use robot or agents? So by the way, what are agents? I'm using this word agent. What is an agent versus a robot? Robot is physical, right? Robot is physical. Maybe an agent is more like on the screen, you might find an avatar, for example, right? That is what is an agent, right? So can we use agents for something, maybe for as a teacher, how can I use it? Yes? What can we use it for? Maybe I can use it like a teaching assistant. Yes? Maybe there are kids who want to learn some language. Maybe I can use an avatar or an agent to teach language. Yes? Possible? Right? Maybe a doctor. How do you think a doctor can use an avatar? Yes? Maybe they can be used as a receptionist, right? The patient comes, maybe the receptionist talks and maybe gets to understand, okay, what doctor would you like to visit, and then maybe it schedules an appointment, right? Things like that. So this whole thing can be done even at home, right? So you can be at home, you can open a web interface just like ChatGPT, right? And maybe you can talk to the agent, right? And maybe book an appointment and come at the right time, right? If the appointment is at 11 o'clock, you can come at 11 o'clock, right? A doctor can use it even for diagnosis. Can they use maybe an X-ray, using an X-ray machine can diagnose? Is it possible? Or it might be possible soon, maybe. Yes? So these are some use cases, right, where a teacher can use, maybe a doctor can use, right? Suppose you want to make Vadodara a better city. How can you use AI? How can you use AI to make this a better city? What could be some ways in which you can use it? Can you use it for traffic management? Yes? Can you understand traffic and maybe using that understanding make traffic better, for example? Can you use it for pollution measurement? Yes, and then see some action can be taken. So there are umpteen number of use cases, right? Can you use it for agriculture, by the way? Can we use AI for agriculture? If at all, where can we use it for? Where can we use it? Diseases, some crop diseases are there, you want to detect. How will you detect, by the way? How will you detect? Will you use a camera, mobile phone, or maybe a drone, which will probably... Mm-hmm. So how will you capture the image? Will it be on a mobile phone or a camera, or maybe a drone will fly? Okay, so crop diseases maybe you want to detect, right? What else could be, how could it be used in agriculture? Where else could it be used? Maybe you want to find out if a fruit is ripe or not. Maybe is it good enough time to pluck the fruit? Can we use a robot to pluck the fruit? Is it possible? I see, it's possible. Okay. So everything seems to be now taken over by the AI thing, right? Everything seems to be possible. So, and you seem to know everything. What do I teach now? What do I teach now? By the way, what is this AI? Is it a black box? I mean, what is AI? We say AI, right? What is happening inside? Maybe it's like a black box, right? You give as input an image, and out comes something, right? For example, have you used DigiYatra? Have you used DigiYatra for travel? So what goes as input, what comes as output? What goes as input and what comes as output? What goes as input? An image of you, yes? You're standing before and you're showing your face and it is taking a picture of your face. And then you're claiming to be somebody, right? It's matching and saying that, okay, yes, this person has access, or it is this person. Say, for example, in Aadhaar, you want to use some service and you're claiming to be somebody, right? And the input is image, out comes yes or no, right? Yes, this is the person or not, and so on, right? So you can think about it as a black box for sure, right? What something goes as input, maybe a crop picture goes as input, out comes what is a disease, right? Now, this much we know, how it is as a black box, but what happens inside the black box? What is happening inside the black box? Yes? What happens inside the black box? an image is going as input, right? And some output is, okay, this disease is disease A, B, C, whatever, right? Now, how does the input, from input to output, what happens? Any idea? What could be happening? Yes? Have you heard of machine learning, the word machine learning? Yes? So what is machine learning? Just give a high level, description. What is machine learning? How does machine learning work? Basically, machine learning, you can say as learning from data, right? You have some past data. With the past data, you can learn a model and you can predict, right? Is it a simple enough description? So what do we mean by past data? When we say past data, we want examples of crop images, right? And you want to have diseases, right? These are all disease A, these are all disease B, right? These images correspond to disease A, these images correspond to disease B. Now, when we say training, what are we doing? We are training what is called a model, right? A model is used for prediction. Now, if you train a model, right, then what happens? You can use the model, right? You can use the model wherein you can give one new image, a new image as input, and you can get, okay, what is the disease, right? Is it A or B or C, right? You get the idea? So what has happened? You had data, and you have a model which you are training, right? So we are using the word training. And once we train the model, then we can use it for what? What can we use it for? We can use it for prediction, right? Given a new image of a crop that we see, now we can predict, is it A or B? So using the same idea, can we also develop a model for detecting what vehicles are going in the street? Yes? Suppose I give you a small image where there is a vehicle, okay? Now I want to find out whether it is a two-wheeler, three-wheeler, four-wheeler, right? You want to find out. Can we use the same idea? Then for training, what will we do? What will we do for training? We will collect several images of two-wheelers, several images of three-wheelers, several images of four-wheelers, and mark that this is two-wheeler, this is three-wheeler, this is four-wheeler, right? Now, given a new image, what will we do? We would have learnt a model here. We will use that model and try to predict, right? We will try to predict that this is a two-wheeler, three-wheeler, and so on, right? So are we on the same page? So what have we learned? We have talked about machine learning. We have talked about data. We have talked about learning a model and then using a model to predict, right? If we can learn a model, then we can predict, right? So this is a good start. I mean, this is what is trying to solve an AI problem using machine learning. So first half is done. I mean, AI is done to pretty much, right? What exactly happens, maybe we'll see. But this is pretty much the main idea, right? Now comes the another word, which is called generative AI. We talked about AI. Now comes generative AI. So what is generative AI? This seems to be a buzzword, right? Everybody is using generative AI. So what are we generating here? What are we generating here? What are we generating? In ChatGPT, what are we generating? First, we are generating one word, right? We are generating one word at a time. We are generating sentences. We are generating paragraphs, right? We are generating answers, right? The key point is we are generating one word at a time, right? We are generating one word. You might have seen this already in your Gmail and all, right? When you try to write a sentence, it predicts the next word, right? So that is pretty much the basic technology, right? How do you predict what is the next word? Previously, you were predicting a class label, right? Car or bus and so on. Now you are predicting, instead of that, you are predicting what is the next word, right? If I say 3 words, you should be able to predict, okay, what could be the next word, right? Humans can do it. We want machines to do it. And because we are generating a word, these are what are called generative models or generative AI, right? Now with this, can you also generate an image? Have you seen AI generating an image by any chance? How do you generate image? prompt. So what kind of prompt can you give? Generate an image of a person who is old and maybe wearing something and so on, right? You can just give a prompt and it generates an image, right? So there, what are you generating? You are generating 1 pixel at a time, right? You are generating 1 pixel at a time and you generate a full image, right? Just like you generate a word at a time, you are able to generate an image. And you can give some inputs, right? This is what is called prompt engineering and so on. So given some prompts, you are able to generate an image, right? Where could this be useful? Where could this be useful, generating an image? Architecture, excellent, okay. Sorry? Marketing, fantastic. Where else can we use it? Maybe a journalist can use it for generating a report, maybe, yes? Somebody can generate an essay, images. I mean, where all can we use images? Yes, so there are lots of applications. You can generate maybe almost a PowerPoint presentation, right? You can have a text here in the left. You can generate some suitable images on the right, right? Can we think of even generating a movie? Is it possible? Does it sound very outrageous? Can we generate a movie? Yes, it's possible. You have already seen that it is possible. From the script you take as input and we will be able to generate a movie. Can you do it? Can you do it for me? I mean, that will be a lot of very good use. Is it possible already? Have you seen it or you think it is possible? Maybe it's possible, yes. Maybe people are generating some short videos like that, yes. But do you think that could be the future where somebody will just have a script and then you give it to AI and then out comes a movie itself? Do you think that is possible? Possible or not? How many of you think it's possible? Okay. The center, they're not very positive. Why you think it's not possible? Too difficult a task? Too difficult a task, but at least you will see that in the near future, right? Maybe in 3-4 years, you will have maybe an actor who will just sign up for an ad, right? They will sit at home, they will give their images or 3D models, and you should be able to generate an ad with them, right? They don't even need to go out of their house, right? So those are starting to become possible, right? So that is what is generative AI, right? So what is the difference between AI and generative AI? We talked about AI, we talked about generative AI. What is the difference? In AI, what are we doing? We are giving an image as input, right? And out comes some label or some class, right? Whereas in the case of generative AI, what is the output? The output is the image, not the input, right? The input is maybe some description, right? And out comes the image. So you get the difference? Suppose when we say sentiment classification, right? Is this an AI task or a generative AI task? Sentiment classification of a sentence, okay? I give you a sentence. Now you have to tell whether it's a positive sentiment or a negative sentiment. If you use AI, is it an AI task or a generative AI task? It's an AI task, very good. If I say, I want a sentence with a positive sentiment, and you use some method to generate a sentence, is it generative AI or is it AI? Generative AI. Now it is clear. When you say generative AI, you are generating sentences, you are generating images, right? Whereas in the case of AI, we say we are giving as input those, and we want to find something about it, right? We want to know something about it. Okay, that's very nice. Have you heard of neural networks by any chance? Have you heard of neural networks? Anybody has heard of neural networks? Nobody? Okay, now you can use your ChatGPT, Meta AI, whatever you want. You tell me what is neural networks. What is neural networks? Let's see who is the fastest. What are neural networks? What are neural networks? Anybody found the answer? What are neural networks? Subset of machine learning algorithms. But what is characteristic about neural networks? Anything in particular? They are inspired by what? Human brain, right? They are inspired by human brain, and they are a subset of machine learning models, right? So let us call them models. And typically, what we will be dealing with are these neural networks, right? So now one question is, machine learning has been existing for a long time, okay? I mean, it is not very new phenomenon. It has been existing for a long time, right? Now, why is it that very recently, in the last, I don't know, maybe like last 10 years, 12 years, we start to hear more about AI, right? AI used to exist even before, right? 1950s, 60s itself, people were talking about AI, right? But now people are much more serious about AI and generative AI. What is the reason? Any idea? Why a very recent focus, starting from say 2012, right, on AI and generative AI? Any guesses? So the reason is neural networks used to exist even before, right? But then now we have a special class of neural networks, what are called deep neural networks. Have you heard of this word, deep neural networks? Deep learning. I think you should get used to these two words, deep learning, deep neural networks, because the much recent advance of AI and generative AI is possible because of what? Can you repeat the word? Deep neural networks. Can everybody say? Deep neural networks, right? It's a very, very important aspect of why we now see that AI and generative AI are becoming possible, and it is creating lots of application, is because of deep neural networks. And in 2012, right, particularly in 2012, you see that this whole deep neural networks came into the picture, and they revolutionized the last 12 years, okay? Heard of, when we say chat GPT, right? What is GPT? People say chat GPT. What is GPT? What is GPT? Use your meta AI quickly. What is GPT? What is GPT? We use so often, chat GPT. What is GPT? Yes? Very good. Can you repeat, what is it? Generative pre-trained transformer, okay? So there are very important words there. Generative tells us that it is actually a generative AI model, yes? Generative. Pre-trained as in it is already pre-trained, we don't have to do anything, right? And transformer is a particular type of architecture, right? Transformers, right? Transformer is a very important aspect of modern AI, right? You should at least know the word. What does that GPT mean, right? Transformers. Okay. So who is heading OpenAI by any chance? Do you know? Sam Altman? Yes. Very good. Good answer. Do you know who got the Turing Award? Have you heard of Turing Award? Use your Meta AI for finding out what is Turing Award. What is Turing Award? Turing Award is given in which field? Computer science. Very good. Sorry? Computation, computer science. Nobel Prize of Computing. So did anybody recently get Nobel Prize for AI related work? Do you know? There's a person called Jeff Hinton. Have you heard of this person? Jeff Hinton got Nobel Prize, yes, along with one more person. So that person, Jeff Hinton, also got the Turing Award, right? Turing Award is the highest award in computer science. 3 people got it, okay? Along with Jeff Hinton, 3 people got Turing Awards. Who are they? Who are the 3 people who got Turing Award? for basically deep neural networks, bringing the deep neural networks into the reality, right? Who are those three? Yann LeCun, yes, Yoshua Bengio, and Jeff Hinton, right? So Yann LeCun, by the way, do you know where he is now? Yann LeCun. Who is the head of Meta Research? Who is the head of Meta Research? It is Yann LeCun. Yann LeCun, in fact, visited India recently, right? He is heading Meta Research. So what is good about Meta Research versus OpenAI? So when we say OpenAI, do you think all the AI that they produce, are they putting it in open source or not? What is open source? What is open source? When we build something, right? If we put the code outside for everybody to see, that is open source, right? As simple as that. Do you think OpenAI is open or not? Yes or no? OpenAI is not open. Okay, so they don't put their code in the open. Previously, they used to do that, but the moment they hit ChatGPT, they closed everything, right? They made everything closed. Nobody knows what is inside, what is happening, whereas Meta's models are open, right? So what is the model that is powering the Meta AI that you see in WhatsApp? Have you noticed it? Llama, right? Llama 3.1 maybe, yes? Llama model. Is Llama in the open source? Yes or no? Yes, it is in the open source, right? So two contrasting approaches people have taken. One is to put it in the open source so that developers like you can work on it, build on it, and so on. And then there is OpenAI, which is not open source, right? Okay. So now maybe I'll start using my slides. Let's think about these things, okay? What we want, what we have, what happened in 2012, AI in human world, and the final question, what should you do, right? This is an important question. Given that AI is around, how should we think about AI and how using AI, right? How many of you think we should use AI? How many of you think we should use AI, okay? How many of you strongly feel we should not use AI? How many of you think we should not use AI? Nobody? Everybody thinks yes? Why? Why we should not use AI? Maybe you're right, you tell why. Ethical problems, right? Ethical concerns. What is your main ethical concern? I see. So you're afraid that tomorrow we may not have much to do, right? That's the concern, right? And some of our white-collar jobs might be taken off, right? For example, we pride that we have a very big software industry, right? Now, what is going to happen if out of 10 jobs, maybe 6 jobs are gone, right? So what are we going to do? So these are concerns, right? So on one hand, you're concerned about jobs, right? That's one concern. There is also concern about risk, right? For example, it could maybe use some private data. There could be so many other risks, right? Somebody might create what are called deep fakes, right? And maybe cheat in some sense, right? Using AI and so on. So there are those risks as well, right? So we need to be aware of those risks, right? And we need to also think about, okay, how can we address those risks, right? We need to address those risks. At the same time, we need to also benefit, right? If we don't embrace, for example, the AI technologies, maybe what job you could have got, maybe somebody else is going to get, right? Because they are embracing AI, right? But at the same time, if somebody is always embracing AI and not developing their skills, right? They're also going to have problems, right? Suppose you have somebody coming with a mic and asking you for an opinion. You cannot type in ChatGPT, get something and talk, right? You have to talk, right? You have to be in meetings, right? You have to be talking to people. You have to get things done. So you need to also invest in your own skill sets, isn't it, right? So you need to invest in your skill sets, right? Your talking skills or your linguistic skills or whatever intelligence somebody mentioned, right? We need to invest in all those skills, right? So can we use AI in an intelligent way where we can actually enhance our skills? Is it possible? For example, if you can build a training platform where you can actually have conversation with an avatar and improve your conversational skills, I think that's good to go, right? We can basically benefit from AI, right? Which is I think very good. At the same time, if it so happens that for certain tasks, routine tasks, if we can use AI and speeden things up, right? Do all the due diligence. We can also use AI to do some of the tasks very quickly, right? For example, some of you did it now. I mean, you did not know, but it doesn't matter. As long as you get the right answer, it's good, right? You can benefit from that. Maybe you can do a much more detailed reading later, right? But you can get a good start, isn't it? At the same time, there is also a use case where we could also have autonomous robots, for example, right? Where could you use robots where you don't want to do it, but let robots do it? Is there a use case like that? Maybe in a manufacturing place where it could be risky to do something. Maybe you want a robot to do it. Maybe in a nuclear site, you don't want to change a wall because it has radiation, right? Maybe you want a robot to do it, right? So you could also have really use cases where a robot or a avatar can act independently, right? For example, suppose you have tested a software very well, right? And it is working very well. Maybe you can use it like a tutor for a kid, right? For example, you want to tutor math for a kid, right? And if the AI is there and ready to go, then you can use it as a tutor, right? Autonomously. It's not actually, there is no human to monitor, right? It's an autonomous system, right? But it can have its use case, right? So there are three types of use cases that we are talking about. One where we are using it for developing ourselves, right? Maybe our speaking skill, communication skill, we can develop ourselves. The second one is where we have a companion. Maybe I put a glass, right? And then I go to a store, and the AI is telling me that, okay, this item has this problem, you have this allergy, don't take it, right? So you are working with AI. Human and AI are working in tandem, right? And you are benefiting from it. And then the third application is when AI is autonomous, right? It is autonomously working, and it can be of benefit to you, right? So there are all types of applications that are possible, right? And we can benefit from some of these, right? So now let us ask, what do we want? What can humans do, right? Humans can walk, they can manipulate objects, they can hear, see, understand, right? These are human actions, right? And some of us are good at certain things, right? We are good at, maybe some of you might be good at linguistic skills, maybe you become journalists, maybe you become lawyers, right? So this is the multiple intelligence theory from Howard Gardner, 1993. So whenever I'm talking about people and ear, or maybe people and what I'm talking about, just make a note of it. You might get it in your tests. You have your test, right? Do you have a test from this talk? So watch out, okay? Whenever there is people, just watch out, okay? Don't tell me later that I did not tell you, okay? So what did Howard Gardner propose? He proposed multiple intelligence theory. There are 7 intelligences here. So how many of you like in this set linguistic intelligence? How many of you like linguistic intelligence here? Nobody? Few of you, okay. Musical intelligence, some of you? Yes? How many of you like interpersonal intelligence. You can be good managers, right? You can talk to people, get things done, and so on, right? So you have different types of intelligence here, right? What this tells is, of course, humans can do certain day-to-day things, but we are all different, right? We are all different. We have different levels of intelligence with respect to different dimensions, right? And here is one such, clustering of abilities or intelligence, right? Ability to do certain things, right? For example, there is also bodily kinesthetic intelligence, right? For example, people who are good at that, maybe they can dance or they can do certain types of work that is much better than others, for example, right? So this is what humans are good at. Now, what do we want? We want robots to do something, right? So what are the things that we want robots to do? Robots or agents to do? We want robots that can move, robots that can do tasks with hand, agents that can observe, agents that can talk, right? We have so many things that we can do, we want robots to do, right? Okay, so this is the main message I want to convey, right? How we should think about robots or agents is as follows, right? We should think about, for example, without robots, right? How can we be great humans, right? How can we be great teachers? How can we be great doctors, right? And here is where we can use AI maybe in an offline mode, right? We can use it in an offline mode to train ourselves, right? To become better teachers, better doctors, and so on. And maybe with robots, right? With robots or with agents, right? Think about the glasses that you have, for example, right? Maybe a doctor has a glass, and maybe they are reading some X-rays. Maybe AI is able to point out something that they are not able to see, right? Things like that, where you can actually use robots or agents and become greater, even greater, right? So the point I'm making is, when you think about AI, think about how can I use AI to become great? How can I use AI to become even greater, right? If you are not great, you will not become greater. First, how do you become great using AI is a very important point. For example, the example that I gave where you're improving your communication skills is where you're trying to become great, right? Maybe you're a doctor, you're using Meta AI or ChatGPT to learn and discover newer research and benefit from it, right? Where the final learning happens here in the brain, right? You become great, right? Now, if you have ChatGPT and other things which is available, then you can probably become greater, right? So think about what could be a way in which you think about AI, right? And of course, you will need robots to do certain things like what we see here, maybe visit nucleosides, fix issues, which are the autonomous robots, right? So there are 3 different types of use cases which we should be aware of, okay? And this is a framework that we can use to think, okay, how can I use robots? Okay? So what could be different types of applications? If you are wearing the hat of a mayor of a city, right? You want better traffic management, better pollution control, better waste management. Maybe you're a farmer, you want better soil, better weed removal, like what somebody was saying. For a teacher, maybe better content, better delivery, better evaluation, right? Or a doctor, where you need maybe better X-ray, better blood tests, better diagnosis, and so on, right? So everything we can try to make it better in terms of application. And what do we have? So this is what we want, right? This is what we want. Now, how do we go about achieving what we want, right? So what do we have? What do we have in our hand? That is what is machine learning, right? Predictive analytics or predictive analytics type of problems. And we have machine learning as a tool, right? Where given new data, you can predict, right? That is what you want. And the machine learning is one way to build such things, right? You have data, you train a model, and then from the model, you try to predict, right? So suppose you have some examples here, right? Suppose you want to do spam detection, right? The input is an email, and in your training data, you have spam or not, right? Emails, spam or not, you learn a model, and then you can predict. Given a new email, you can predict that this is a spam or not, right? Or even you can predict what could be your score, right? Suppose you have a model which takes as input your 10th standard and 12th standard math score, okay? And it will predict your CGPA at the end of the first semester. Would that be good? Yes? Then how do we build that model? How can we build that model? What you need past data, maybe your seniors data, where you have the 10th mark score, you have the 12th mark score, and your seniors first semester scores. With that, you build a model. And today, if you need your mark, what do? You take your 10th score, your 12th score, and you try to predict, right? You try to predict what could be your first semester CGPA, right? So you can have a model which does something like that, right? And then you are already familiar with this, right? So if you see, how many of you read Google News? Do you read that? Yes? So how does Google somehow manage to cluster items, right? It manages to put all the similar type of news in the same category, right? So that is what is called clustering, right? Where you can take a set of news articles and try to cluster. So now how does it work? So the spam detection problem, right? It's what is called a classification problem, right? So what happens in a classification problem? You have a set of data points which are represented in what is called a feature space, the green and the red. Now you have to find a model, right? You have to find a model which will divide this into two classes, right? If you can find a model, then you can differentiate between cars, bikes, right? Autos, and so on. So this is an analogy, right? You have a classification problem. So how does a model work here? This is the starting line that you have. With training, you want to make sure that after you train, you get a right model, right? So what is a right model here? A right model could look like this, right? You have a line which separates nicely the green and the red, right? So this is what we call as training, right? When we do training, you have a model which is in a bad shape, but after training, the model is in a right shape, right? Now the model parameters are basically the parameter which define this straight line, right? There is a slope and an intercept, and that is what you're trying to learn, right? So I'm just trying to give you some basic idea of what does it mean to train a model, right? When we say somebody trained ChatGPT, they are doing something similar to this, right? Here the number of parameters is very less, right? Just a slope and an intercept, right? That is the only parameter you have. In ChatGPT, you might have millions and billions of parameters. But the idea is the same, right? The idea is when you train, you're trying to find a model which tries to do the task at hand, right? Here it is the classification task, right? Similarly, as we said, we can also try to find a way to predict your first semester score, right, based on 10th marks, right? There also the model is very bad in the beginning, right? The model is very bad at the beginning here. But here we want the model to do well. Now the line has to turn, right? It has to fit this data. Now when you start fitting this data, you might get a solution like this, right? So you have your past data, which is basically these points here are the past data. You have tried to fit a model, which is the blue model. Once you have the model, then you can use it for your class, right? How do you use it for your class? For your class, you know what is the 10th mark, right? A new point comes, you know the 10th mark. Now you can use a model, which is the blue line, and then predict, right? And predict that, maybe this person will get 80%, right? You can use the model to predict. You get the idea? So similar to this previous one, right? In the previous one also, if you have a new point, see here, you have a new point, right? For the new point, you can predict whether it is a spam or not. So what will be the color of this data point? What will be the color of this data point? will it be green or red? Red. Why red? Why is it red? It is red because it is to the right of this line, right? You have learned that to the right of this line are the red points, to the left of this line is the green points. Because this point is in the right, you say that this is also red, right? So you can give it a color, right, saying that this is a spam, right? Similarly, you can do the prediction here as well, right? You are trying to fit a line, and you will be able to give what is the predicted score in the first semester, right? Similarly, the third problem, which is you have a set of data points, maybe different news items, and you can cluster these news items and make a grouping, right? And so that tomorrow, if you are given a new item, you can see whichever is the closest, and then you can give it a color, right? And so on. So this is just to get a rough idea, right? This is not a perfect idea, but you at least understand what is behind the black box, right? So what is behind the black box? You have a procedure called learning algorithm or a training algorithm. Using past data, you train a model. The model has parameters. Given a new image or a new sentence, right? You use what is called inference algorithm or a prediction algorithm. Using this, you can predict, right? Whether it is a car, auto, or a bad sentiment, positive sentiment, negative sentiment, all that you can do. And you can also evaluate, right? You can also evaluate whether you have done it correctly or wrong, okay? So you get a rough idea what is happening. You just need only a rough idea. You don't need precise ideas. Rough idea is good enough, okay? So what is a new thing in terms of neural networks is they have what is called a hidden layer, right? You have what is called a hidden layer, and think about this as what is in our brain, right? You see an image, and then you have lots of neural networks, neurons that are there in the head, right? So you can think of it as multiple layers of processing that are happening. So this is a simple single layer neural network, which takes input, right? Suppose 4 and 5 is the input. It multiplies with some number and does some processing, and eventually you're trying to predict whether something is a cat or a dog, let us say, right? Things like that. So you use what are called neural networks in order to do the prediction, right? Which are more complex models. So I will not complicate things for you, but I'll just try to tell something that is more at a higher level, right? So here is a task that we have, right? The task is, suppose you want to classify if an image is a car or not, right? What do you do when we say machine learning framework? In a machine learning framework, we will show examples of car and examples of not a car, and then we are trying to classify whether it is a car or not, right? And here is an interesting example, right? So now let us see one interesting thing, right? So when we say we want to identify something is an aeroplane or not, right? What is the challenge involved, right? What is the challenge involved? The aeroplane that you want to detect or recognize could be in very different viewings, right? For example, you could have what is called occlusion. The object itself is not fully seen. Maybe it is in a different lighting condition, right? Maybe you have a very different pose. It's a different viewpoint, right? And you could also have aeroplanes which are very, very different from each other, right? Now you have to find a way by which, right, you can say all these are aeroplanes, right? So the traditional way of doing it was as follows, okay? So the traditional way of doing it was you have an image, you extract some features, which is called feature engineering, and you get a vector. And with this vector, you're able to differentiate between cars or not. Okay, this was the previous paradigm, right? And the way they did it is somehow they tried to extract what are called parts of an image, right? For example, eyes, nose, and so on, right? So here, if you can do that, then if you have to recognize a face, then what do you need to do? You need to get that there are these two eyes, one nose, and a mouth. Then it is a face, right? So this is what is called a bag of parts representation, where you're trying to represent a face using parts, right? And you have all these different parts, and you can recognize these objects. So this is what is called a feature engineering paradigm, whereas in the case of deep learning, right? So I'm just going to stop at deep learning, and then we'll stop getting technical, okay? So don't worry. So first we introduce what is called a neural network. Neural network has hidden layers. Then comes deep neural networks, right? What are deep neural networks? So you have input, and then one hidden layer, two hidden layer, and so on, okay? So there are so many hidden layers through which you are passing your input, and that is why it's a very, very complicated model, right? It takes a lot of energy. It's a highly nonlinear model, right? And this is the success that is helping all your ChatGPT, right? When you say you're running ChatGPT, what is happening? Underneath that, you're using a deep neural network like this, which you have learned with past data. And with new data, you're able to predict what is the next word, or you're able to predict what is a car, whether it is a car or a bike, and so on, okay? That is what you want to do, right? And why 2012 was a very important year? If you see what happened in 2012 is very interesting, right? Till 2012, people were using not deep neural networks, what are called shallow neural networks, very, very shallow networks. Whereas in 2012, for the first time, they started to use what is called 8-layer network, right? Previously, you see, it was a shallow network, shallow neural network, whereas in 2012, what is called AlexNet, right? The first time they started to use a 8-layer neural network, and with time, slowly the number of layers are increasing to up to 150 layers, right? Really, really deep neural networks, right? And only when they start to use these very deep networks that you started to see that you're beating the human performance on a task like this, where you have an image and you have to predict what is the object there, right? What is that object? Is it a ship or a car or whatever, right? They started to get very, very big performance improvements. So the bottom line is, when we say we are using ChatGPT, or when we are using, say, big AI models, right? They are actually what are called deep neural networks. Please remember that. That is a very important keyword that we are using, what are called deep neural networks. At least that should be a message, right? So this is the deep neural network that we are talking about. Okay, that's good. So this is in 2012, starting from 2012, the performance has been better and better in terms of error that it makes on recognizing these objects, and we have had a very, very good run, okay? So now let us move on to the generative AI problem, okay? We talked about the AI problem. Now let us talk about the generative AI problem. So here is the DigiYatra example, right? So what happens in a DigiYatra example? Here also you have an image which looks like this going as input, right? And you extract some features, right? And you're able to classify that, yes, this is this person or this is not this person, right? So these are the 3 Turing awardees we talked about. So their main contribution was to somehow use deep neural networks for interesting applications, right? So these are the 3 people that we talked about. So who is the meta AI person here? Who is the meta AI person here? Yann LeCun, right? And Jeff Hinton, he also got the Nobel Prize, right? And he was at Google for a long time, okay? And this is Yoshua Bengio, right? Yoshua Bengio is famous for the generative AI task, like predicting the next word and so on. So here is one clue for you, maybe for your test, I don't know. Jeff Hinton, he is famous for this backpropagation algorithm, which is used to learn deep neural network. And this was in 1986, okay? This was in 1986, very important date, year. And this is Yann LeCun. Yann LeCun in 1990s, right? He invented what is called a convolutional neural network, which is a very important breakthrough that happened in 1990. But only in 2012, we got the deep neural networks, okay? So that's also an important thing that you might want to remember. And thanks to this, you have lots of interesting applications, right? You have object localization, detection, machine translation. You translate from one language to another. You recognize somebody's speech, medicine, skin cancer detection, autonomous car. Everything got possible because of this deep neural network, okay? So when you think about AI, what has happened in the last, after 2012, it has been amazing in terms of leaps and bounds that what has happened, okay? So please make a note of this in terms of deep neural network. That is what I would emphasize. Now let us think about generating a word, okay? So how does generating a word look like? Because we are talking about generative AI, right? We are talking about generative AI. So how does this work? How can we try to predict what is the next word? Mary had a, what could be a next word? What could be a next word here? Yes? So Mary had a little lamb, right? So this is how you predict for every situation that you have now. You give us input and say, okay, what could be the next word? And there could be different words that are possible with different probabilities. And you pick the one which has the highest probability, and you can say that Mary had a little is the next prediction, right? And that's how ChatGPT predicts, right? It predicts one word at a time, isn't it? So for example, you can ask, can you give me some ideas for what to do while visiting Munich, right? Munich. So next, it first selects one word which is absolutely, right? And then again selects another word and so on. So here when it has predicted till here, then it is looking at what could be a possible set of words that can come after this, right? And it looks at probabilities and finds that, cathedral is the most appropriate word. I will predict cathedral, right? And that's how it predicts one word at a time, right? So what is this word here, transformer? Have you seen this word, transformer? What is transformer? Somewhere we said, what is a transformer, right? What is a transformer? ChatGPT, GPT, right? T is transformer, right? So this is basically a large model, a deep neural network model, which can be used to predict the next word, right? Which is what ChatGPT is all about, okay? So here is a very brief history of transformers. 2017 is when this paper called Attention is All You Need, which is the basic paper for transformer that was started, right? So this whole revolution of transformers started in 2017, and then with time, there has been lots of interesting developments, including ChatGPT and so on, okay? So now let's not, so I think you might have used some of these, right? Where you can ask, you can give a prompt, explain the moon landing to a 6-year-old in a few sentences, right? This could be a prompt that you have. And you see that thanks to the ChatGPT's training as what is called a instruction it can handle, it starts to generate, right? People went to the moon and then they took pictures and so on, right? So it starts to understand instructions, right? I think this is prompt engineering, maybe not so interesting. I think this might be a little hard. Okay, let me go to the main point that I want to mention, right? So the main point that I want to mention is, what are the leaps that we have had, right, towards what is called artificial general intelligence, right? Particularly, this is OpenAI's viewpoint, right? So the first leap is what is called convolutional neural networks, which happened in 2012, okay? And then the transformers, 2017, make a note, it has years, so please make a note in case you want to do well. Leap 3 is what is called conversational AI or ChatGPT, right? You are familiar with this. Starting 2022, we have the third leap, which is the conversational AI. These two are what are called foundational models, right? Very foundational work. After this, we are starting to have AI which can have conversations, AI which can talk, right? And then the next one is AI which can reason, right? And then subsequently, the leap 5 or level 3 is what is called agents, right? What are agents? Agents are where you can say, write a program to do trading trading for stocks, okay? So the AI will do trading for you and generate money for you. Okay? So this is the kind of agentic AI that people are talking about, where you can make an agent autonomous. It will do things, it will find out things, it will take care of most of the things because it can now reason, right? Because you see here itself the reasoning is ready. Now if an agent can reason, then it can take instructions from you, it can reason, it can do things on its own, and maybe give you money, right? Isn't it sounding very interesting? These are interesting possibilities which are right there. Maybe the next 2-3 years, we will see that agents are going to start doing things which we never imagined to do, okay? And people are talking about already how AI, how you can have the level 4, which is innovating AI, the level 5, which is what is called organizational AI, which means that you can have multiple people working on different things and actually forming an organization which is all agents, not even humans, right? Everything is done by agents. Somebody is just giving an instruction, right? Just an instruction. It is able to explore. For example, you want to find out a solution for an online problem, right? You employ few agents. The agents will try to do different things and find out that this is a good business model, and they'll probably be able to create a solution for that business model, right? A lot of interesting possibilities are out there that people are talking about, okay? So you might have seen how you can give a prompt and generate an image of a person and so on. So now let us go on to see some videos and maybe reconcile what we were thinking about, okay? So this is to show the kind of robots that are already possible, right? You have already seen some of those videos, maybe. It's not coming. Why there is noise? Noise आ रहा है. Sound audio नहीं है. Okay, never mind. So you get the point, right? So you're starting to see some very interesting robots which can do very, very interesting stuff. कुछ साउंड आ रहा है. कुछ और साउंड आ रहा है. So here are robots that can dance. Okay, so you get the idea, right? Robots which can move, which can fight, which can dance, and so on. And here is some examples, maybe which are closer to your interest in terms of agriculture, right? What robots and agents can do, right? Particularly robots which can maybe look at crops, which can pluck flowers, pluck fruits. You have drones which can do certain things, right? So a lot of interesting possibilities. So it is able to recognize different vegetables. Something has a fungus. Okay. So you get ideas, right? So I think these are fairly public domain, so you can see some of these interesting applications where you have drones which can even do it can put fertilizers and pesticides, pluck fruits, categorize them into different sizes, and so on, right? So very interesting applications of AI. Okay, so maybe let's go back and maybe we can try to conclude what we have so far, right? So we have very interesting applications. Audio stop kar dijiye. So we have very interesting applications of AI in healthcare, like what we discussed: disease diagnosis, treatment development, personalized care, in education for personalized learning, right? Be it in terms of student engagement, administrative tasks, right? Or even like a tutor that can teach a kid, right? Maybe the prompt can say that you're a tutor, you respond in what is called Socratic style, and then you try to ask, okay, how do I solve this linear system of equations, right? So maybe a kid is asking this question, right? And with Socratic method means that you don't tell the answer, but you give clues, right? And then you try to eventually make the kid learn, right? So here you see that the whole thing proceeds by giving some clues, not the exact answer, but eventually the kid is able to pick things up and so on. Okay, so there are also, like what we said, AI in agriculture, so many different types of applications that we just saw in a video, right? And you can do sorting and so on. And there are other applications in traffic, like car detection, number plate detection, infrastructure-based traffic analytics, and so on, right? So the main question now is, okay, you have all these interesting applications. Now, how do we govern AI, right? Because there are going to be a lot of risks. Somebody was saying it is very risky, right? So there are issues related to privacy. There are issues related to security. There is issue related to fairness, transparency. Is it explainable, or we don't know what's happening? It's a black box. There are issues related to safety, performance, third-party risk when you integrate, and so on, right? So one way to look at all these risks is to look at this, what is called European Union AI Act, right? Where they have come up with different risks associated with different AI models or AI applications, right? You have something which is minimal risk, so there is no restriction. You have something what is called unacceptable risk. This is something like a nuclear power, right? It is unacceptable risk, so all these should be banned, right? And then there are these two other categories, which is high risk and limited risk, right? Where you can operate, right? It is safe to operate, and high risk could involve some amount of applications like vocational training, safety components of products, and so on. And here you have a mitigation mechanism, right? How you can mitigate it in order to avoid the high risk, okay? And then there is what is ChatGPT type of thing, which is limited risk. So ChatGPT is not a high risk, but it is a limited risk, where you have to mention that this is a AI generated content, right? Suppose you are building an application where you are creating a customer care application, right? And your customer care is not a human, but actually an agent, right? Now you have to signal to the user, right, saying that it is AI generated content, right? You cannot act as though it's a human speaking, right? The other person might just want to speak only to humans, right? So you have, here it's a limited risk, it's not a huge risk, but at least you should flag that it is a AI generated content. Or even a content that you generate, maybe a person speaking a video of a person, which is generated by AI. It is always important to flag it and say that it is AI generated content, right? Otherwise, you can use it for deep fake and very bad applications, right? So this is one way to address AI applications, right? Now the question is about jobs, right? To begin with, most use cases will be like helping doctors, teachers, practitioners, right? Humans are in charge, right? And AI will just do an assist. But we are also seeing that increasingly you are starting to have applications where you have agents. Can you book a hotel on behalf of you? Can trade stocks algorithmically, right? Now the question is, how are we going to regulate, right? And this is still a open area or early days in some sense, right? And with time, you will also see that AI might start to take jobs, right? It might give some jobs, right? Maybe in certain areas where it is, we are using AI for newer applications. Maybe there are some new jobs that are coming. But you could also see that there are going to be lots of jobs that will be taken, right? For example, in software and so on, right? There is already signs that certain jobs can be easily done by machines, right? So we have to, on one hand, we have to manage this challenge, right? We have to invest in our next generation in terms of excellent teachers who can make use of technology for routine tasks, and then maybe they can focus on higher order skills, right? By this, what I mean is, suppose you have a virtual agent or an avatar which can teach ABCD, okay, or basic words maybe in English, right? The agent can do it, right? Whereas a teacher can do much more deeper cognitive, philosophical type of teaching the teacher can do, right? So for that, we also need very good teachers, right? So that is probably a way we could look at how AI and humans can play a role, right? So here is one interviewing platform that we built, where this is a UPSC interviewing platform, which is an example where you can actually use AI to train people, right? You can train people to be better communicators. So this is a UPSC interviewing platform where a candidate who is sitting there, they are appearing before a panel of 5 people, right? And they are giving an interview, and because of that, they are getting trained, right? How do you face a UPSC panel? Okay, so I think there's some problem with the video. So the idea that I mentioned, right? So what was the key idea that was used in our method was to generate what are called follow-up questions, right? If you can, audio stop कर दीजिए please. कुछ आवाज आ So the key idea was to generate follow-up questions. Just like ChatGPT can generate a piece of text, you can actually generate what are called follow-up questions based on what the candidate answers. We were able to generate follow-up questions, and we could have a interviewing experience, right? Which is an immersive interviewing experience. Okay, so maybe to conclude, so what will be a good conclusion, right? So let's conclude it this way. I think all of you will become professionals as you go forward. Maybe some of you will become teachers, doctors, lawyers, journalists, managers, right? You will get into different professions, right? And what could be a take home from this talk, right? The take home from this talk is, if I am a teacher, right, I should aspire to become a great teacher independent of technology, right? I should not say that always I need technology. I should be a great teacher already. You should be a great manager already. You should be a great lawyer already. You should be a great journalist already. You should be a great doctor already, okay? Now, you can, if you are a great doctor or a great teacher, right, you can actually use tools to become greater, right? You can use agents or robots to become even greater. If you don't aspire for the first one, right, if you are already not a great teacher or a great doctor, then there will be others who will be better than you, right? So always invest in your skills without technology, and with technology, try to become even better, right, even greater, right? That would be a very good use of your time, because if you don't do it, there will be others who will do it, right, who will probably use technology better and do a good job, right? So make sure that you are pro-technology, you use technology, because technology is basically leapfrogging at a very high pace, okay? Things are moving at a very high pace. If you don't use technology, you will be left behind, okay? So you have to use technology, and there will be also situations where robots or agents are becoming autonomous. They are completely autonomous, and society has to find a way to control them and use it in really good applications, right? And if it is, say, an application which is on the internet and stuff, you have to manage that risk, right? You have to manage that risk based on it is a limited risk or a high risk. You have to mitigate the risk, right? So we can think about it from a risk point of view. As a society, as a country, we have to become ready for what is coming, right? What is coming in terms of AI and the way our jobs are going to be threatened and so on. It is very real, okay? It's not something that is not real. By the time you graduate, you will see that. You will see that there are a lot of things that can be automated, right? So really invest in your skills, which is independent of technology. Invest in your skills with technology, right? And just embrace technology and see what you can do with it, okay? So that is the message I would like to leave you with. Do not, do not ignore technology. Embrace technology. Develop your skills, and develop your skills to use technology as well, okay? So thank you, everyone, and thanks for patient listening.
Dear students, so it's quite easy to use ChatGPT and other AI related models, but it is really difficult to understand that how these kind of models work. And I really appreciate, I must say thank you, a big thank you to sir, Dr. Dinesh Babu sir, who has given us this opportunity to learn, to understand the intricacies of this kind of world. For me, it is completely an alien picture, because I do not belong to an engineering background. At the same time, I do not understand these things. No doubt we do understand that life has become quite easy But when we look at the intricacies, we can understand that how difficult it is at times to understand how preparedness, how detailed work, how algorithm and all together come and make something this quite easy for human life. As a token of gratitude from our university, I would request Ms. Nishu Chaudhary ma'am to come forward and felicitate sir with a memento.